I'm very excited to introduce the one and only Leif Peterson talking about Dart's type system, a subject near and dear to my heart.
It's the type theory talk for today. It's the only one. Okay, how's the volume? Is it good? Yeah, sounds like it. If I'm yelling at you too loud, sorry. So sound Dart. What's all this about? So about a year and a half ago, we started looking into how we could layer a sound type system on top of the existing Dart language and Dart type system. The reason that we did this kind of crazy thing was to enable us to improve the developer experience with the Dart dev compiler. That's going to be the next talk, so I'm not going to talk about that a lot. This talk is about what we call strong mode, which is the sound type system that we designed. I want to talk about what it is, what it does for us, and how it can make your lives as Dart developers better. So I'm going to start out by talking a little bit about what soundness is in general. I think this in some ways this is obvious, but I think it's really worth talking about what the core of soundness is when we come down to it. So really, soundness is about a relationship between the programs that you write, the code that you write, and the values that show up in the code at runtime. So we say that a type system or a language is sound if whenever you say that something is a dog, when your type system says this expression, this piece of code has static type dog, everything that you get out at runtime in that position is going to be a dog and nothing else. So if I write some code like this, for example, that I think it's pretty clear what the intent of this is. I'm saying I'm going to feed the dogs, and my intent is to pass it a list of dogs, right? So I've written the type list dog to say, hey, this code should take dogs. So if I were to come along and read this code, I might very reasonably act under the assumption that all of the things that reach the variable Fido are going to be a dog. And that's a good thing, right? So Fido is probably going to have a feed method, and Fido will probably be very happy to get a juicy bone there. So that's very reasonable as a programmer. I've expressed my intent, and if I'm refactoring, I might come along and act under the assumption that the things that are going to get here are going to be a list of dogs. But in fact, in regular Dart, even in checked mode, there's no guarantee that the things that show up here are actually going to be dogs. I might get a number, or I might get a string, or I might get something completely unexpected. So that, despite the intent, we're not living in a world where things that are claimed to be dogs will necessarily be dogs. In regular Dart, you might get something completely unexpected in a place where you expected to get a dog. There's lots of reasons why you might care about soundness. The one that I want to start with is why soundness mattered to sort of us as people implementing Dart. And so I want to talk about compiling first. So when you're compiling unsound code, you have to be very cautious about what things might show up where you expected a dog. This isn't a real problem for a VM, for a just-in-time compiler, because a just-in-time compiler can make optimistic assumptions, and then later on, it can change its mind. It can say, oh, I got a cat. I will recompile this code, patch it back in, and everything's good. So it can do the really fast thing optimistically and change its mind later. When you're in an ahead-of-time compiler, you have to actually plan for the worst case. You need to deal with all of these different possibilities statically. You need to worry about what happens if it doesn't have a feed method, or if it has a feed method which expects different sorts of parameters, or it has a feed setter or getter or something. So all of those things are things that can possibly happen at runtime. You need to be prepared for them. So that makes your code much bigger. It makes it harder to generate readable code if you're in an ahead-of-time compilation setting. So the goal, the original goal, the original motivation of looking at this sound type system is to enable a better ahead-of-time compilation system to give a better developer experience so that we could very quickly generate very readable code that you could very easily debug on any browser that you wanted. And we're going to talk more about that in a little bit. Right? So if you are working with a sound language and you're compiling this code, you don't now have to worry about very unexpected things. You don't have to worry about strings. You don't have to worry about numbers. you can just assume you're going to get a dog. Everybody likes dogs. Now, when we came out with strong mode, some people just turned out to kind of like strong mode anyway. So even some people who are not actually using the technology that we're building over strong mode started turning on strong mode because they found the things that we were building into it were useful to them as developers as well. Flutter was one of our early customers, and they were a super useful one because they gave us lots of really good feedback, but they were not actually using the technology that we're building under this. And we saw this a lot where people were, people were using strong mode to get the benefits just of the stronger type system. And so strong mode is sort of now, I think, expanding to being used more and more for these other benefits that we're talking about. So when I had this code, when I'm working with code, when I'm writing code, when I'm reading code, when I'm maintaining code, those are all situations where having reliable types also can provide some benefits. So if I'm reading code, it's okay to sort of assume that when the user wrote list of dog that was their intent and that's what it will be, but it's a little unsafe, right? You could be relying on accidental properties of the code that aren't actually tracked by the type system. And even this is even bigger when you go around and you start incrementally modifying code. If you don't get the feedback from the type system, it's harder to maintain very large amounts of code. And Google has large amounts of code. So our goal was that all these people who were doing all this work to write types in their code would get all of the benefit that they really weren't getting. What we were seeing was that people were writing this code sort of as if it was a statically typed language, as if it was sound, but they weren't getting all of the assistance that they could because the language sort of it wasn't sound, and the types can lie, right? So our sort of motto for strong mode is that we want to make it so that the types can't lie. So what is strong mode? There's really three pieces here. There's a type system. There's a set of runtime checks that sort of deals with the remaining dynamism in the language, and then there's some type inference, which are there to keep the language feeling darty. So I want to talk about each of these three pieces, starting with the sound type system. So there's really, actually, in some ways, surprisingly little that we had to change to make the type system sound. There are really just three major sort of things we had to change about the way the type system works. The first is that we had to change the way override checking works. So dog here inherits from object. Object has a hash code method that is declared to return an integer. Standard Dart doesn't object if you change the return type here to object, and string is a perfectly reasonable object, so this is a perfectly valid override in normal Dart. It's a bad idea. Please don't do this. Strong mode will yell at you. My cat will look at you funny. It's a bad idea. Similarly, covariant method override, so that was the return type. If you want to change tighten the type on a parameter. So this, in some ways, looks like very reasonable code, right? So I have an animal, and I say, well, it's got a chase method, and the chase method, an animal chases some animal. And now I'm going to take a cat, it's an animal, and it will chase mice, right? This seems quite reasonable, but the problem is that if I assign a cat to an animal, I can then send that cat off to chase a dog, which is going to make for an unhappy cat. So strong mode will yell at you if you do this. Please don't do that. Another one that I think is actually surprisingly important is getting rid of these sneaky dynamic lists. So lists and in general all sorts of generics. When you're working with generics in Dart, there's actually kind of a cool feature of Dart where you can take a generic, you can instantiate it with dynamic, and now you can use it as anything, right? So here I've made a list of dynamic and I filled it with dogs. This is allowed to masquerade as a list of cat. It's kind of a cool thing, but it totally breaks all your soundness. Strong mode will yell at you. My cat will look at you funny. Please don't do that. Similarly to the override case, we also restrict function subtyping to be the usual covariant, contravariant on the parameter, covariant on the return type. If you have something which registers a cat and expects a callback which returns a cat, In regular Dart, this is assignable, a function which returns an animal is assignable, so you can pass in something which returns a dog when you register your cat. That's not going to make anybody happy. Strong mode won't let you do it. Please don't. So these restrictions are basically enough to make a sound type system, sort of. So what's the sort of? We didn't want to go fully, in part because we have a huge corpus of code, right? And people like writing Dart code. So we don't want to come along and say, you are all bad people and wrong, and we want to punish you for writing Dart code. We want to keep the language as Darty as possible. So one of the ways we did that is saying, okay, there are certain patterns which are not quite statically sound, but we can recover soundness by injecting runtime checks, sort of like checked mode, but a very small subset of checked mode. So here, for example, is actually perfectly valid strong mode code. Even though this looks really kind of silly when you write it this way, it's actually pretty reasonable, right, in some ways. You have something which is an animal. It might be a cat. In this case, though, it is in fact not a cat. We will statically let this through, but we will yell at you at runtime. So strong mode has an implied runtime downcast here, which is going to stop you from actually putting a dog where a cat is when you actually get there at runtime. So that's the runtime part of it. There's also some checks required to deal with covariant generics. We keep generics as covariant, which is not totally sound, but that works for us. So there's a caveat here with the runtime checks. These are only implemented in the Dart development compiler so far. We've had a lot of success with strong mode and a lot of success with the dev compiler. We are moving towards implementing these semantics more widely in our tools and supporting them more broadly so that you can make use of them. But so far, you're only going to get those runtime parts of the checks when you're actually running in the Dart dev compiler. So that means that you can actually break our type system in a certain sense if you're using one of the other platforms. But you still get the benefit of the static checks anyway. And if you're running in checked mode, you actually get most of those checks as well. The last piece I want to talk about is type inference. And this is the really cool part, I think, because this is a part where we give you a whole lot of benefits. And it's also the part where we do things to make working with this stronger type system still feel very Darty. So in regular Dart, when someone writes var, like here they say fluffy, var fluffy, what that actually means is that the type of fluffy is dynamic. So that's a little surprising in some ways. A lot of people think of this as saying, you know, this is maybe type inference or I don't know what, but really, really, really it means dynamic. And what that means is that if I do something like this, where I take a substring of fluffy, this is perfectly valid code in regular Dart statically, right? Because, you know, it's dynamic, and dynamic has all methods. So we change that in strong mode. In strong mode Dart, saying var means please infer a type for me here, rather than just treat this as dynamic. So when you write code like this, we will infer a type cat for that variable, and we will yell at you. It's not just var. Basically, any place that you leave off a type in code in strong mode, we will try to fill in a type for you using type inference. So here I have a map literal and a string, inside of a list. These in regular Dart are interpreted as dynamic lists and dynamic maps, so you could have lots of stuff in here that you didn't expect, or you could add something later on and you would get no checked mode errors because the type of these things were actually, at runtime, are dynamic. In strong mode, we will actually push down this outer type into this term here, and we'll say, okay, because you're saying that X is supposed to be a list of map from string to ints, this is clearly going to be a list of maps from string to ints, and this map is going to be a string to int thing. So statically, we figure this out, and then we set that type in runtime, and now any checks later on, if you were to add something which was not a map from string to ints, we could give you a runtime checked mode error. Similarly, if you override a method, here we have animal, which is overriding the toString method, and you leave off one of the types, we'll say, okay, the superclass already declared this method with a type, so we will infer a type for you. Even more interesting, if we have a big composite expression like this, whoa, did I just lose? Still hear me? Okay. If we have a big composite expression like this, we can push types all the way through this to get lots of interesting type information, which is just super useful, and I'll give you an example of this in a minute. So here we can come along and we can say, look, this is a list, you put a cat in it, we'll infer that this is a list of cat. That means that, well, the parameter to map is going to be cat because I'm coming from a list of cats, and that means that the things that I'm returning here from c.owner are people, and that means that this variable is going to be a list of person. I can infer all that for you, and I can give you error messages and completions based on that. So the goal is to be sound, but still very terse. So we really wanted to keep the Darty feel, and we really wanted to keep the ability to write code that had all the nice things about Dart, but still was sound. And I think so far, I've been really happy with how this has worked out. We have a very large corpus of code that has been converted to strong mode, and it's actually really pleasing how small the changes are in a lot of the cases. And that's actually been hugely valuable for us as people designing this type system, is that we have a huge amount of code to learn about what actually matters. And one of the reasons I really like that is that that's allowed us to stay very simple with our type inference. We've very deliberately chosen to stay kind of in the subset that is very fast to compute and is very predictable, doesn't tend to have the sort of spooky action at a distance that you get sometimes with stronger type inference algorithms. But we can still cover most of the common cases that actually matter in practice just by looking at a little regional piece of code. So this is super exciting, and we're still improving on this. I think it's really cool. So I wanted to show you this actually in action because I think it's really nice to see how this is integrated into the tool system. So, what's that?
Can you zoom in?
I can try. Shoo boy. Let me try. How are we looking there? Yeah, that's getting better. Okay, so let's work with that. So this is, here's a simple hierarchy of types here. We have people with a name, we have animal with an owner, which is a person, and we have cats and dogs extending animals, and now I want to do a few things with my cats and dogs and animals. So if I start out with strong mode off, there's actually no errors in this code right now. Sorry, let me get us back into restart our analysis here. So there are no errors in this code. And if I come along here, so this is my example from before. I'm making a list of cats and I'm mapping over it. And now I want to put a lambda in here. So one thing that you can see right away is that if I try to get a completion on this variable c, I'm not going to get any suggestions other than the things on object. And the reason for that is that if you look at what the analyzer thinks about map, all it knows is that it takes a closure from dynamic to dynamic. So all it knows about C is that it's dynamic. So I might, make a guess as to what I want here. That looks right to me. And I don't get any complaints here, but I still don't get any useful completions out on the other end either, which is kind of a bummer. But fortunately, it's very easy to fix this. So if I enable strong mode and I come in here and I reanalyze my code, voila, I get a nice error message telling me that, in very small print, that the monkey boy is not defined for the class cat. So that's really pretty cool, and you can actually poke around in here and see all the pieces of how this is getting figured out. So if I go up to here to owner, in the regular Dart, this is declaring a variable, a field, which is dynamic. I can look at this now, and I can see that actually we've inferred a type here for person. And using that, we can, when we come down here and fix this code, so when I come to C, so if I look at C here, I can get completions for owner here. And the reason is that when I look at the type of map, the analyzer has been able to figure out that this is expecting a function from cat to person now, and it's going to return an iterable of person. So again, using that same process of starting at the list and saying, okay, this is a list of cats, pushing that types all the way down, we're able to get types all the way through there. And now if I come out to the other end here, I can actually now get completions for name, for example, as well, all using type inference. Yeah. It's super cool to see in action, and I'm really excited to see more integration into the IDEs. I think we can get a lot of benefits here. I wanted to show one more small demo just because I really like this one because this is an example of stuff where even code that is very well tested can have latent bugs in it that you wouldn't catch without something like strong mode. So this is a similar hierarchy here. I have animals, cats, and dogs, and I have some API which returns an iterable of animals. And the interesting thing here is that in practice it actually returns a list, right? But its contract just says that it returns an iterable. Now, if you write code, unfortunately this is right on the line here, but if you write code that calls this API and then call the add method on the thing you get back, you're not going to get any errors in the regular analyzer, and you're also not actually going to get any errors in your code, even if you test it very well, because in fact, this API satisfies a stronger contract than what it declares, and you are now relying on that contract. So you are more tightly coupled to this code than you may have intended. And we actually found these sort of latent bugs when we were converting code to strong mode. If you go over here and you re-enable strong mode, you will actually get an error saying, hey, you said that my animals returned an iterable, and you're trying to use it as a list. You might want to fix that. So I was really excited to see that. You can play with this now in IntelliJ. You can also you can use you can use Dartpad. You can just turn on strong mode with a little button down here. I don't know if any of the other stuff that's out there. I saw someone using like a visual code thing. I don't know if you can use that, but awesome. That's what I like to hear.
And also the CLI works. If you create analysis options, it works with analyze.
That's right. So certainly if you use the Dart analyzer from the command line, you just pass -- strong and you are good to go. So I pulled a little bit of a fast one on you there. If you're looking closely, there's some funky stuff going on here, right? What's this parameter to map? So one of the things that was missing from Dart when we tried to go to implement strong mode was generic methods. And that's actually really important if you want to track types around reliably, because otherwise your functions like map, they lose type information as soon as you flow into them. So anytime you had composite expressions like this, you tended to lose all of your types. So generic methods were added to strong mode first. So sorry, I should have put this one up. Here's the regular definition of the iterable class. Or this isn't quite how it's defined, but get the idea. It returns an iterable. It takes in a function which just returns dynamic. In strong mode, we added via a comment syntax generic methods so that you could declare this as having the kind of expected generic type, where you tell it the return type and get back out an iterable of the appropriate type. And with type inference, we could basically insert this, and you didn't even really have to change the way you were using it most of the time. Comment syntax, bad. So I'm very happy to say that we are very close to being able to fully enable the full syntax. We are putting generic methods into the language. So people have been hard at work sort of integrating this so that your code will work with regular mode or with strong mode. And I'm really happy to see this happening. It's a thing. Okay, so just a brief mention of some stuff that's coming. We're still working really hard on strong mode, trying to make it better, taking feedback from people and looking at code. There are some knobs we're adding, and we're going to keep experimenting, sort of seeing what are the best ways to tighten the system, or maybe to support more dynamic code. So we're still working on that stuff. Generic methods are coming. We've been experimenting with supporting covariant overrides. So I gave you that example of the cat chasing a mouse and said, that's bad code. But there's actually some very valid use cases for code like that. And so we'd like to try and find a way to make that work, and we're experimenting with that. We also have some non-nullability experiments. Yeah, love to see this happen. We hope we can make this integrate nicely into a nice Darty language. So this is a thing. It really is a thing. So this is really widely used in Google. We have a lot of people converting code to strong mode. It's growing very rapidly. We're moving packages externally to strong mode, and we really encourage you to make new code strong mode clean. I think it will make your lives better, both in terms of the tooling that we can provide for you using strong mode to sort of bootstrap, but also I think it'll just make your life better in general, just giving you a better experience with the language. So give it a try. Thank you.